want to start off by talking about the difference between relational and non-relational databases. These are kind of like two flavors of database, you could say. So first, let's talk about relational. And I just kind of want to, we're going to be using MongoDB, which is a non-relational database for its simplicity. But relational databases are extremely popular, and they're just everywhere. Like there's a lot of relational databases. So I kind of want to make sure that we have a general understanding of their topics. Let's talk about relational databases. Relational databases. Oftentimes called a SQL database, SQL. Does anyone know what SQL stands for? Close. Structured query language, yeah. Structured query language. Internet stable. It should be okay. Corey and Toby, can you see okay?
Yeah, I cut for a second, but it's good now.
Oh, okay, that's weird. So that's a SQL database. And you'll see this a lot of times. The databases will just stick the name SQL in it. So you have like PostgreSQL and MySQL and SQLite and others. There's like Oracle, which doesn't do that because they're too cool for school. The easiest way to understand how a relational database is structured is to think of an Excel sheet, an Excel table. Okay, if you wanted to, let's say you just popped open a Google Doc with an Excel or with a sheet, was it Google Sheets or whatever, Excel sheets, Excel document, and you wanted to, let's say we're creating, let's say we're creating an application that saves to-dos. That was unoriginal, whatever. We're doing to-dos, we're saving to-dos. If you were doing this in an Excel sheet, what would be represented by the rows? Yeah, a new to-do, right? And what would be represented by the columns? Yeah, exactly, the properties. So up here, you'd have like, here's a title, and yeah, maybe like a due date, and a completed Boolean, and so forth. And then each of these, so these we call table properties in a relational database, table properties. Sometimes they'll be called attributes. And these are called records.
Records and properties?
Records, yeah, and properties, yeah. Okay, so every row here represents a new to-do. Every column represents a property of that to-do. So in a relational database, like I mentioned earlier, every item that gets saved to the database will automatically be assigned an ID. So let's just say 1, 2, 3, 4. And this is something like buy milk and buy bread and, I don't know, take out the trash and so forth. Okay, every single item is going to be assigned an ID. Okay. Now, what if we introduce to our database users? We want to be able to save users to our database. Well, we would create another table for users. This is so that it's not just me that's allowed to use the system. And what is this going to represent, the rows? Each individual user, so records of users. And these will be properties of the user, right? So maybe like first name, last name, age, and of course, ID. Got Bob's role, 32, 1. My wife Sarah's role, 32, 1. No, not 1, not 1. Okay, why can't she also be 1? Yeah, the IDs need to be unique. Terrible database for both number 1. Yeah. Okay, so is it okay to have the same ID here as this ID has here? Why? It is, why?
Because they're separate tables.
Yeah, so because it's on a different table, it's okay for them to be unique. Because when you're referencing an ID of something, or rather when you're referencing like a to-do item, what you're gonna say, or what you would say is go to the to-dos table and look up for the ID of, 3. And this right here is going to make it okay, because if I were to look for the person with the ID of 3, then I would be looking for a user of 3.
It's kind of like arrays, like, to do an array of these to do each object that has different properties.
Uh-huh.
That array is named
Exactly, yeah. In fact, when we get to MongoDB, it's going to literally be like that. That's exactly what it is. So yeah, for those online, what Jordan said is it's kind of like an arrays. Like array, var to-dos equals an array can have ID, or rather an index of number 3, and so can a var user is an array with an index of 3, and those indices don't like clash with each other because they're different entities that they're referring to. It's a good way to think of it. Okay, so the reason that these are called relational databases is because we need to find a way to make it so that users are associated with to-dos, right? Because we don't want just a list of to-dos and a list of users. We need to make it so that a user, like if you pull down a list of to-dos, that you're pulling only a current user's list of to-dos. In relational databases, there's 3 types of relationships. There's one-to-one relationships. There are one-to-many, or many-to-one, it's the same thing, and many-to-many. Okay, can anyone think of a good example of a one-to-one relationship? No, it doesn't have to be to-dos and users. It can be any 2 things that generally have a one-to-one. What's that? Well, those all belong to the same unit, right? They all belong to the same person. Those are properties of a person. A vehicle and a driver, but a driver can own many vehicles, right? Or do you mean at any given time, like the person physically driving? Okay, yeah, you can only. Well, a child has more than one parent typically. So that might be a one-to-many. Well, that could be a many-to-many because any given parent might have multiple children as well. Okay, so let's go with this idea. Like if you're driving, well, then there's like those, those cars when you're learning to drive where the passenger is also kind of driving too. The idea that The relationship I usually think of is a person and their driver's license or social security number. Yeah. So one person, any one person, has only one social security number, and each social security number belongs to only one person, right? One-to-one relationship.
So why would there just be a property? Like, is it just to split up the table?
Yeah, this is assuming that the social security number is a different table, which maybe it wouldn't be. But like driver's license might be, like it might have a state property and an expiration property and an issued property and like a donor true or false Boolean property and stuff like that. Yeah.
I took a database class. I company that has sales. Each salesperson has a team, and it's on each salesperson can have their own table of various things, and it's going to be IDs that are also associated with which product is sold, so that they can connect.
But that's a good question because let's come back to that because that's like a design decision. You might say like, well, I only need to know the social security number, so I'm not going to create another table just to have like a social security number and an ID of the person that it belongs to. I will just add that to the person table, which is totally legit. Like if that's all you need. So let's say person and their driver's license. What's an example of a one-to-many relationship? Yeah, I think that works. Yeah, if you say mother rather than parent, I guess you could say like mother, because as long as you're not talking about like adoptive mothers or anything like that, right? Because you might have one mother could potentially have many children, and each child has just one mother. Well, I guess you might have like a gay couple, so maybe this doesn't work. You have two mothers.
Yeah.
That might be a many-to-many relationship.
Siblings.
What about the birth mother and children?
Okay, birth mother and children. Let's do that. Yeah. So even if like let's say one of the birth mothers in your database only has one child, does that change it to be a one-to-one relationship? Why not?
Because it's about the type object that you're like comparing.
Yeah, well, and there's potential, right? There's potential for her to have more children. So even if like, let's say you only have one person to put in your database to start, you wouldn't say, well, that one person has just one child, so it's a one-to-one relationship. Rather, you'd say, but if I'm gonna add more birth mothers to my database, I'm gonna want to have it be a one-to-many relationship so that in the future, I can plan for a birth mother to have multiple children. Whereas person and driver's license, you can be fairly safe making it a one-to-one relationship because even in the future, every person is still going to have one driver's license. Of course, then you have like international licenses and random stuff like that, but whatever. What about a many-to-many relationship? Friends to friends. Yeah, you could have like any given person in your database has many friends and each one of them has many friends. I like to think of like a college course or class to students. So why is that many to many?
Because many college courses have many students, and many students also have many college courses, so they may not all be the same.
Right, yeah, and I always like to say like any one college course will have many students, and any one student will have many courses that they are taking, classes that they're taking.
You'd actually extend that example to all three of those. Like you could do instructor for students for one to many, one instructor has many students, and
Yeah.
or one instructor could teach many college courses. Each student would have a student ID.
Student ID, sure, yeah, exactly. So when you're thinking about your database, it'll just be a good idea to make sure you kind of understand like the relationships that all your entities are going to have. Let's come back to one of the things that Mike mentioned. So if we have, like, why even have multiple tables? We're making a users table. We have a first name, last name, let's say age. You're going to get an ID. And then let's say we want like their driver's license number. DLN, driver's license number. This might be a completely legitimate way to do that, as long as we only care about the number of the driver's license. As soon as we start saying like, well, I also want to add, you know, the expiration of the driver's license expiration. And oh, I also want the driver's license issue date. And I want, you know, whether or not they're a donor, an organ donor, and so forth. All of a sudden, like our users table has a huge section that's all related to driver's licenses. And it seems like this is a good instance in which we say we need to break this off into its own table. Okay, so, but that's, yeah, that's a really good question. Another thing you have to think about is what are you going to query for? So we'll talk about this. We'll talk about this example a little bit later when we talk about structuring a MongoDB database. But let's say you have a user and you need to know that user's address. Like you want to save that user's address. So you might say, well, I'm just going to do first name, last name, and then address. Okay. Because you saved the address in the user table, you will only ever be able to get an address in the context of a user. Meaning if I want to, like if I ever wanted to get, you know, see who is living at 123 Example Street, that makes total sense because you want to know who is living there, which is the user, right? The user who lives at that address. But what if you wanted to get like an array of all the addresses in the database? And you don't care about who lives there, who doesn't live there. Well, now what you're going to have to do is you're going to have to go get all of your users and then just grab the addresses from each of those users. So imagine if you're Zillow. If any of you use Zillow? Yeah, they do like property values and house listings and stuff like that. When you go onto Zillow, it doesn't necessarily care who lives at what house. And in fact, it doesn't have like a user of Zillow that's associated with each house. Instead, they need to be able to get a list of addresses and not care about the people, right? So they don't want to wait for a user to sign up for their system to then have that house be showing up on Zillow. Instead, they have every house already on Zillow. So in that case, what they probably do is they say, we're not going to make the address part of the user table. We're going to create an address table and have its own properties there, like the street address and the, I don't know, like the home value and whatever. The city, state, zip, you know, everything. That is square footage, number of bathrooms, number of bedrooms, all that kind of stuff. And so they make a separate, or they would probably have a separate table for like an address or a listing or a house or whatever they call it. Does that make sense? Why they're separated? Okay, let's talk about how to create a relationship. Let's go back to our to-dos. So to-dos and users, what kind of relationship might this be?
One to many.
I could see it being one to many because why? Each to-do has one user probably that it's associated with, and each user probably has many to-dos. Now, if you've ever used something like Wunderlist or the Apple reminders or something like that where you can share them with people, then it might actually become a many-to-many, because like my grocery list with my wife is shared, and if I check something off, it is checked off on her list too. And so that in that case might be many-to-many, but let's consider it a one-to-many for now. This is oftentimes drawn to look like this. Nope, other way. This is it's called crow's feet notation because it's got looks like a little crow's foot. This is saying many to-dos and one user. It's just this isn't actually the number one. It's just a line through the line going this way, but it looks like a one, so I guess that's why it's one. So that's how you kind of draw out a one-to-many relation. You don't have to memorize that, but just in case you see it. It's like lightning now. Okay, so if I have a to-dos table and a users table, how can I connect them? How can I connect a to-do to a user or a user to a to-do? Okay, an ID in what way?
Every top to do as to
Yeah, so the database is already going to give every to-do and every user an ID.
Another table that just has the ID and then a bunch of other IDs.
That's true, actually, for a many-to-many relationship. That's exactly how you do it in a many-to-many. We'll get there. But with a one-to-many, what were you saying?
That's key value pairs. Like you have a key of like one thing that is connected over to that other one.
Yeah, and so these IDs, like it kind of depends on your perspective, but if I'm a to-do, this ID, my ID, is oftentimes called a primary key. It's just just think of it as another name for ID. And if I want to say this to-do belongs to a user, then in this table, I'm going to add what's called a foreign key, which just means it's like this is kind of local, and foreign means it's from another table, from a foreign table. I'm going to add a foreign key. I'm going to tell it which table to look at, users. And then this is going to be the ID number of a user that this to-do belongs to. Now, when you're mapping or when you're creating your relationship and it's a one-to-many relationship, typically what you'll do is you'll put the relationship or you'll put the foreign key on the many side. Why do you think that is?
Because the menus, like, it makes more sense because each one of those menus could have like one of the ones from over there.
Yeah, if I were to flip it over here, instead of having like this might be like the user ID property or something, instead of having, let's say I put it over on this side and I say, here's the to-do IDs. Well, potentially how many IDs, like this might end up being an array of thousands and thousands of ID numbers, right? If somebody has a huge to-do list that they never finish. So, well, I guess even if you do, it just marks it completed. So the alternative, and this is possible, like you can set it up this way where you have an array of IDs of to-dos, but typically they say, well, just put it on the many side so that you just have a single ID to the user to whom this to-do belongs. Does that make sense? That's okay. With a one-to-one, good driver and a driver's license, I think you can just kind of choose. Usually what they'll do is they'll take the owner, I believe, like the driver owns the driver's license. And so actually, no, I don't know that that's true. I think you get to just choose which side you want the ID on. So you can say, well, I'm just going to make a driver's license ID number. And it corresponds to, like, if this is ID number, 4,365, that's the ID of this driver's license. Then here you would say, Joe Schmo owns driver's license ID number 4365. And what's nice about this is that it's a reference to another table where you can get more information if you need to. And this table is available to query if you just need that information without the context of the person to whom the driver's license belongs. Like if you're the Department of Transportation and you just need a list of all the valid driver's license, or like let's say invalid driver's license numbers out there, then you could just grab them. And maybe for some reason you don't care who it belongs to, you can just grab them without having to grab the driver first. And I should make this clear. This 3 would maybe match with the person with an ID of 3. This is Joe Schmo. Does that make sense? Are there questions about how this works?
Yeah.
Yeah, questions or yeah, it makes sense?
Yeah, it makes sense.
Okay. Mike, say what you were saying again about having an intermediary table.
So I guess if you have many and many, it makes sense because then you can use another table to connect them. So you have an ID of students, an ID of courses, a table in the middle says which student ID matches which courses.
Yeah. Exactly. So I could theoretically say, okay, student number 1 is, Ben, and he is taking this array of courses. He's taking courses 9 and 11. Or I could say course number 9 is being taken by student number 1 and 3, and kind of have to choose, but because it's a many-to-many relationship, it would always be an array of some sort. And so the typical way in a relational database to associate these is to create what's called a join table. And there's like 5 or 6 different names for this kind of table. Intermediary, join, I can never remember the other ones, but if you talk about a join table to anybody, they'll who knows databases, they'll know what you're talking about. And a join table associates a single ID with another single ID. And so it would say like student number 1 is taking course ID of 9. That's one entry in the table. Student with the ID of 1 again is taking course 11. That's another entry in the table. Student 2 is taking 9. Student 2 is taking 10. Student 2 is taking 11. And this allows us to not do an array, but rather have this join table where I can reference which courses they're taking. And these are usually just called like literally student underscore course. Like if this is called student, then this would be like students. If this is students, then this would be students underscore courses. Just because it's a joint table. It's usually what the name is automatically generated to be, at least in Postgres. Yeah, anyway, it's a pretty smooth solution to understanding, or a pretty smooth solution to a problem that could arise with having arrays of IDs. Let me see if I missed anything. Oh, while we're still on this, I would recommend finding like we're not going to go deep into understanding SQL or like learning the syntax of SQL. I would recommend finding a course of some sort. There's a Codecademy course. There's I'm sure a bunch of Udemy courses. There's probably a ton of free YouTube videos that talk about the like learning SQL. It's not difficult, but just so you're kind of familiar or like not totally foreign to it, you'll see things like select everything, select star from the users table. And this is a SQL command. You type this in, as long as it's in a SQL context, it will say, oh, it will go to the users table and it will select everything, every single record from the users table. Or you might filter it by saying something like where, like first name equals Bob. And this is going to say, look at everything in the users table, but only return those where the first name is Bob. And I don't remember the syntax for this. It might not be capitals and last name equals, Smith. Or you might have or last name equals Smith. So everybody that has a first name of Bob or has a last name of Smith. So that's kind of what SQL looks like. The only reason I recommend looking into it is because some interviewers tend to ask about SQL. The reason we haven't used SQL in the class is because most jobs aren't hiring people to do, like most jobs hiring junior developers aren't hiring junior developers to mess with the database. Usually they reserve that for more like a mid-level to a senior level position. But they still tend to ask about it in interviews just to see if you've worked with SQL at all. We use MongoDB for its simplicity. It's very popular with the mean stack. Well, it's required in the mean stack because that's what M stands for, but it's very popular with Angular, Node, and Express because of how easily data flows right into it. And I'll show you why in a second. So that's why I've used a non-relational database. But it's also very fast. MongoDB is a very fast database. So they all have their strengths and weaknesses. And when you're doing like a real project at your job, they will have chosen a database that has the strengths that they need for their specific application. Maybe, yeah, if they did it right. They also will oftentimes choose many databases. Like they'll choose a few different kinds. It's common to have like a non-relational database for saving some data and a relational database for saving other data, just because that way they're optimizing the pros and cons, well, optimizing the pros of each of those databases. So it's much more complex in the real world than just having like one database and then you're always going to use that database. I think when we went to Overstock, they showed us like their site map, which was, or their whole application stack. And it was like it was like spaghetti. It was so hard to read. It wasn't the code, it was a diagram of their like structure. their whole corporate structure with their tech. And they were using like at least 4 or 5 different kinds of databases. So yeah, in the real world, it'll be split up a little more. Questions so far? Some of the lingo that we talked about with relational. Let's start from the bottom. What is a record? Yeah, you could say like a row in a table. You could say it's like an instance of something. But it represents a single entity, right? A single thing, like one user in the database. A table is what? Say that again. A box of the information? Yeah, I mean, yeah, you can think of that. A box or like a collection of records. Right? It's a bunch of records that are all similar. I should say collection of records that are similar. Meaning they're all users, right? It's a users table or it's a to-dos table. And then a database is a collection of tables. Okay, to familiarize ourselves with non-relational database lingo, the equivalent of a record in a non-relational database is called a document. It's the same idea. It's an instance of a thing. It's called a document. The equivalent of a table is called a collection. And this is still a database. Okay, so this is just to be familiar with the lingo of a non-relational database. So document is a record, a collection is a table, database is still a database. A collection is, well, actually let's do this. Thinking in terms of JavaScript, a document is an object. A collection is, what do you think? An array of objects, right? Of documents. Document, document, document. And a database is, I guess, kind of like an array of arrays, or rather an array of collections. See what I did there? Yeah, it's more like a file that contains a bunch of these collections. Oop. Okay. It's just comparing lingo. This one's pretty straightforward. Non-relational databases. Or sometimes called NoSQL. Simply put, what's that? No squirrel. There you go. Oh, except I don't need that last L. Simply put, a non-relational database is just a collection of documents. And like I said, you can think of a document as what you've been using for objects. So this is where it really shines with a full JavaScript stack, because a document looks like this. Hair, true. You thought I was going to say brown, didn't you? Eyes, also true. Okay, and that's a document. It uses a format like MongoDB uses a format that's very similar to JSON that it calls BSON. And I forget what the B stands for, but I imagine it's something like binary, but I'm not sure. You don't have to really do anything with BSON. The tools we'll be using will do everything, dealing with like stringifying and parsing and everything, but just some background. So you can basically think of the stuff that gets saved like a JavaScript object, or if it's a collection, it'll be an array of those objects, right? Now, the way that we're going to be using MongoDB is going to be a little bit of a hybrid between a non-relational database and a relational database. By doing so, we're going to get the benefits of the simplicity of pushing stuff into a MongoDB database, into a Mongo database. But we're going to be able to get the structure of a relational database and the, what's it called, validation that comes with the relational database. Actually, I forgot to talk about that. When you're creating, let's jump back to SQL relational for a second. When you're creating a table, I believe all relational databases, when you're defining what the properties of this table are going to be, you have to tell it what the data type is going to be. Okay, so if you have first name, and when you're first creating this table, you need to say, hey, by the way, first name is going to be a string. Or oftentimes they usually call it like a var char or just a char, meaning variable amount of characters. Okay, but basically the idea is like this is going to be a string. And if you try to submit a record where you say person number 1, their first name is 7, it's going to say no, you can't do that. And it's not going to put something in the database. It's going to spit back an error that says you need to make sure that this is a string. And it really cares about this being a string. Same with like if you have an admin and you tell it it's going to be a Boolean and you submit another 7. It's going to say, no, can't do that. It's going to spit it back, throw an error, and say you can't do that. You have to explicitly tell the database, let's say, like, I don't know, there's a Boolean of likes cheese. True or false? Okay, and when you're creating the database, you have to explicitly say, and by the way, this is okay if there's no value. Like if I submit a new person with the first name and an admin, but without like a likes cheese Boolean, then the database says, that's okay, I'm going to put null there. And it will fill it in with null. So you basically are saying, it's okay to fill this in with null if you need to. But the database needs to have something there. Okay, so that's kind of like the rigidity of a structured or a relational database. But it also comes with nice validation, right? So it's kind of a trade-off. On one hand, it's not very flexible, but on the other hand, it's very sturdy. Like it has the validation behind it that will make sure that you're saving the correct kind of data. On the other hand, with NoSQL, non-relational databases, because it's an object, it says whatever you want to put inside this object is fine. I don't care. Regular MongoDB is like, sure, come on in. Like if you want to submit, like this is the users table. This is the users, I should say collection. And you want to push an object that has like, I don't know, like
A name of 7.
feet, false, and yeah, name of 7. Like, you're welcome to the users party. I don't care. And then the next one, you submit, you know, a name of like a real name, but then like is mass murderer false? Come on, guys. Okay, totally like different objects. MongoDB is like, I don't care. So you want to save it? You can save it here. You save it in the users table, fine. You know, this is like to do title, buy milk. It's like, all right, if this is where you want to save it, go for it. Doesn't care. So it's very flexible, but it has basically no validation, right? So what we're going to be using is kind of a hybrid where we're using MongoDB and we get the flexibility of it, and or I should say that, well, we get most of the flexibility and we get lots of the simplicity of just pushing stuff to the database. But we're using a package on top of it, which this is the official MongoDB, it's called an ODM. It's the official ODM for MongoDB. And what Mongoose does is it allows you to create structures, tell it what the data types are going to be, create relationships between different collections and different documents, and so forth. So it adds on a lot of the benefits of a relational database.
What is this ODM stand for?
ODM stands for Object Document Mapper. If you work at all with relational databases, you'll run into things called an ORM, which is an object relational mapper. It's an internal system for allowing objects between tables to talk to each other, and for you to talk to the database and get data in like a more simple way than having to write out SQL by hand. So Mongoose gives us the capability of querying MongoDB in like a more user-friendly syntax. Okay, you don't have to, I mean, that you don't need to memorize that, but that's what it's called. So let's install MongoDB on our computers. I think, yeah, homebrew. Okay. So this part I want you to follow along with. You'll open your terminals. And I believe everyone should have homebrew by now. Type brew space update. Doesn't matter where you are in the terminal. Brew update. And if it says brew bash command not found, raise your hand. If it's thinking, raise your hand. If you're Tatiana, raise your hand.
Well, it's
Yeah.
Yeah.
Is it doing this
That's
though?
stinky.
It's just like sitting on the next line.
Yeah, pretty much. Perfect.
Oh, why am I in the Impact Hub Salt Lake network?
Because it does that. I swear, like the internet comes out here all the time. And then so it jumps onto your next one.
Jumps onto the other one.
I had
Yeah.
to completely remove mine.
Yeah.
I had like a order, so it shouldn't do the order. So
No, that's how it is.
Okay, online guys, I might drop out for a second. Looks like I already did. Okay, are you guys there? Can you hear me?
Yeah, you were just cutting out a lot.
Yeah, I just deleted the other network that it kept jumping onto. Yes, switch networks. There we go. Did anyone start spitting anything out, or is it just sitting there? You're just spitting things out? Yeah.
Wait. Is that another commander specific?
No, just the
Oh.
one. I
Okay.
had quit mine and started it again because I switched networks. Oh, there it is.
Wait, it's supposed to spit stuff out?
Yeah. Is you still thinking?
Yeah.
We'll just give that a minute.
Yeah, that's how everyone is. You know, you can mess it up. That's stupid.
Any luck? Not yet. Raise your hand if you like it spit out stuff and is waiting for you to type in commands. Yours is still downloading. Oh, you're in your server.
Yeah.
Should I try mine again? Yeah. Is yours like this?
Okay.
Did I restart mine? Oh, it's not blinking. Wait, wait, so it's-
Might have been that we all. Heyo.
Hi. How's it going? It looks like up top it's thinking, so that's. Oh, there we go.
Right. Okay, we are going to use Homebrew to install MongoDB.
Enter.
Enter.
It's version of progress bar.
Still not matter.
Doing weird stuff.
It doesn't matter which folder you're in. Do you like the little beer emojis?
Yeah.
I wonder if they actually make a brew, especially for.
That'd be sweet. Like if the people who run homebrew also brew a brew that's called homebrew.
They probably used to get a cold bottle.
Yeah. Totally would.
Sierra bottle.
What's that?
In the URL, it says Sierra bottle then.
Yeah.
Coming straight from the cellar.
Yeah.
Boring.
Okay. So who's still thinking?
Oh, just finished.
Just finish. Still thinking? Tatiana, Mike, Dustin. It's good. 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 Jordan. Almost there.
Or
Oh, really? You probably had it first and you took all the bandwidth.
Sorry.
It's done? Okay. There's a line right here. Oh, no, wait. Actually, we have a couple things left to do. We need to, so the Mongo database file lives inside of a folder called /data/db. So we need to make that in case it doesn't exist. We say make dir space -p space /data. Don't forget the initial /db.
And we can do this anyway.
Sudo make dir -p/data/db. Yeah, you can do this from anywhere because the slash is an absolute path starting from root.
Password, is it your Mac password?
Yeah, it's the Mac password. Okay, did that work? That work for everybody? We finished that? Okay. Let me post this next command. Oh, this one jumped onto the other network too. Hmm. Fine, we'll just type it manually. Okay, we're going to do sudo CHOWN, change ownership, dash capital R.
Bob, if I have the like little key and I can, should I just clear the screen and not choose the pseudo? I got a password with the key.
Oh, yes.
For your computer, how do you log in to your computer?
And so now, I do this. Why is my computer offline? Guys online, can you hear me?
Yeah.
Yeah, I can hear you.
Oh. All right. Well, I think these are backticks. So it's going to be sudo chown dash capital R, and then this is a backtick. Okay, it's the same key as the tilde, but without holding shift. Backtick ID space dash UN, another backtick, space slash data slash DB. And let's see if this works. Okay. If it doesn't throw an error, I think we're good. Yeah. That work for everybody? Let me, no, I was trying to post this from my computer, but I guess I can just do it from here. Wait, this can't access Slack either. Is anybody else's Slack down?
Mine did.
Yours is down?
Yeah, it says it's unavailable.
Oh, there we go.
Don't worry, we're on the case to check our status page for updates. It's probably just Slack.
Oh, don't listen to that. Oh no.
Well, I got that. I thought you just said so.
Yeah, but it's got the
It still
wrong.
says it's Slack's unavailable when I'm getting what you're sending.
Okay. Well, don't pay attention to the one I just put because the backticks are wrong. So just do this one. Raise your hand if like that just went to the next line and that's okay. Tatiana, are you
No,
typing it
it's
up?
not. It's what's giving me some away. I'm sorry. It's just, yeah. Actually, I was going to think that the first one I got this was it shown for some reason. And actually, I was.
Oh yeah, because you didn't fit the. Oh, you didn't put two.
Sorry.
No, you're fine. Okay, the last thing I think we need to do is do brew services start MongoDB.
I think it's funny how the like has all sorts of different references.
Yeah, it's cute.
And that's it. MongoDB runs on your computer on port 27017. And so don't use that port for your servers. No. Okay,
27017.
got it. Yep, write that one down. Just in case you're tempted. Like, why do I feel like I need to use port 27017? Just don't do it. Actually, it'll just crash.
That's the zip code for Surrey County, North Carolina.
I wonder if that's where they created it. Okay, so MongoDB does, you can think of MongoDB as another server that's running, okay? You've seen me do diagrams like this where I say, okay, you have your client, you've got your server, and you've got a database. And the way that we're going to be doing stuff is you from your client will make a request of your server, and oftentimes, if your server needs information from the database, it will make a request to the database, and then your database will return data to your server, and your server will return that data to the client. So this acts kind of like its own little server. And it's running on port 27017, where your server might be running on port 8000. And that's kind of a similar cycle. It's almost like the server becomes the client in asking the database for information. And then the database returns information, returns a response. Server just forwards that on. Does that make sense? Let's play around in MongoDB real quick, and then we'll be done. If you open up your terminal, again, doesn't matter where you are, and you type Mongo and hit enter. It's going to put you into the Mongo shell. Basically, it's like you are inside the database and you get to look at stuff. You get to see what stuff looks like. So if I say show DBs, and actually this is kind of, I guess, a little bit of a misnomer. So I said that there were documents, collections, and databases. And a database is what?
Collections.
Yeah, it's a collection of collections, and a collection is what? Yep, collection of documents. MongoDB is actually a collection of databases. Okay, so when I go, like each project that you make will probably just have one database with numerous collections, and each collection will have numerous documents, but it'll have one database. MongoDB has the ability to support many databases. So like you'll still use MongoDB for each of your projects and just create a new database for each one. That makes sense. So when I say show DBs, semicolon. Huh? Show DBs. Thanks. Show DBs will list out your different databases. You can create a new database by saying use space and then some database name. Let's say puppies.
Do we need to run that brew services start MongoDB statement every time we're going to start using this?
No, so that's running in the background.
And
Yep. Yeah, it'll restart itself when the computer restarts. Yep. And by the way that like what we're doing now, where we jumped into Mongo, you're probably not going to do this in the future. In fact, at your jobs, you probably won't even have access to the shell for your database, because it's super easy to delete an entire database. It's one command, enter, and the database and all your business is gone. So you won't do this typically. So on that happy note, let's use puppies. Okay, switched to database puppies. If I say show DBs, oh, actually it's not going to show this list here until I create a document. That's okay. Okay, so I said use puppies, and now I have moved from like Mongo, which holds all of the databases, I've moved to the puppies database. Now that I'm in the puppies database, I can like look at the collections and add documents to collections and do all sorts of stuff like that. For example, I'm going to say, in order to insert a new document, I'm going to say db dot, and then whatever the collection name is going to be, let's say owner, or let's say puppies dot insert. Okay, and that's a method, so it takes parameters, or I'm sorry, it takes parentheses, and I'm going to pass to it an object that I'll be inserting. And let's give it like a breed. What's a dog breed?
This is creating a collection.
So this will create a document, and it will also, because it's the very first time I'm creating a document in this collection, it will also create a collection called puppies. So it's pushing this document into a new collection of puppies. So we have a breed of border collie and name. What's our border collie's name? Lassie. Was Lassie a border collie? No?
No, that's even was it? Yeah. What was it? I'm sorry, it wasn't a border collie, it was a collie.
Oh, it was a rough collie.
Yeah.
All right, well, Lassie is a rough collie. Okay, so I'm done. I'm going to hit enter, and it says I've inserted one document. Okay, now if I say show DBs, now that I have a document saved, puppies shows up in my list of databases. I say show collections, and it shows me I have a puppies collection. I probably should have chosen a different name for my database, because now they look the same, but they're different. The database is, there's probably a way. I don't know it offhand, but it's probably easy to find. Okay, I'm going to, let's insert another puppy. I'm going to hit up a couple times, and we'll do the Schnauzer. How do you spell Schnauzer? Schnauzer.
Something like that.
What's that? What's the name? Franz?
That'd be a German name, right?
Yeah. Okay, so I'm going to insert another puppy, and then we'll make Hans the Schnauzer as well. All right. So what kind of request do you think that could be equivalent to in the HTTP world, this insert command? It's like a post request, right? I'm creating a new document. If I want to do kind of the equivalent of a GET request, I'm going to say db dot, and then the name of the collection, which was puppies, dot find, and just parentheses. What dot find says is get me all of the puppies from the puppies collection. Give me all the puppies. And there's my 3 objects. Now, what do you notice is different about each of these objects? They have object IDs. The way MongoDB does it is instead of just calling it ID, it calls it underscore ID. So that's just something to keep in mind. It just uses underscore ID because it's Mongo and they can do whatever they want.
We actually talked about requirements. That's basically everything. Underscore ID because it shows up very top.
Oh, interesting. I hadn't
So we talked about that.
I hadn't considered that. Yeah, so it's alphabetical. Okay, so it added this ID. It's represented by this kind of a constructor called object ID. But this right here is the actual ID. What's in the string? db.puppies.find. And this is whatever your collection name is. Okay, you can also do db.puppies.find, and then if you don't want it to be just kind of inline like that, you can say .pretty. And it will put it out nice and neat in a prettier format. And this is all, you can find all of this in the document that I just posted to Slack. Remember I said MongoDB is welcoming of everything. It'll accept absolutely everything. I'm going to go up to db.puppies.insert and insert like first name is Colin. Last name is Smith. Age is 42. And hit enter, and MongoDB is like, sure, okay, that looks nothing like any of the other documents I have, but it doesn't care. Okay, it just lets it right in. So now if I say db.puppies.find, pretty, there's Colin Smith, right? Totally out of place amongst all the other puppies, but there he is. Okay, this is what Mongoose is going to help us avoid so that we get data consistency where the puppies all are looking like puppies and they all have the same properties and everything. If I want to get rid of Colin Smith because he infiltrated our puppies array, I can use db.puppies.remove, and in parentheses, what's going to go in here? Yeah, well, and it's going to be some kind of selection criteria, and this is what we're going to use commonly. So I'm going to pass to it an object, and I'm going to say, just remove anything you find with an ID property equal to, and then I'm going to take this object ID of Colin Smith, paste it down there. Yeah, well, I'll show you how easy this is, even easier than this. Okay. This selection criteria, this is common. This is something that we're going to see even in other things. So if I say db.puppies.find, remember it got me everything. I can say db.puppies.find, but then instead of not putting anything in there, I'm going to put this object that helps me filter things further down. So I'm going to say find amongst the puppies those that have the breed of Schnauzer. And we'll do a dot pretty just so that it shows up easy. And notice that it just found me, or just returned, the 2 that have the breed of Schnauzer.
a second?
Yeah.
Um,
It's this one.
you like that right result thing?
I copied it and pasted it. Well, I copied and pasted the object ID.
So it'll just say right result? Yeah, so I did that. And then it says dot, dot, dot. I'm just waiting for it.
Oh, you're probably missing a parentheses or quotation mark or brace.
Oh, you have your direction.
Okay, I'm going to create a couple of people. Do you remember the command for creating people or creating a new document? Insert. I'll say name is Bob. Age is 12. You can actually insert more than one document at once if you put it in an array. And then just put commas between each of the objects. So name is Sarah. Age is 79. Name is Jerry. Age is 42. Okay, you don't necessarily have to do this part, but you can if you want. No write errors, inserted 3 objects. I'm going to say db.people.find. For some reason, it didn't make that one pretty, but okay.
So my remove still hasn't worked. And I think I got it right. I know I'll put this in my notes wrong.
Oh, you're not mongodb.
Not even now. Oh. Okay.
Using cookies.
Yeah. That's the same as doing Mongo and use cookies.
Yeah, I think. Try it.
Thanks.
MongoDB has some pretty cool search tools. So for example, I made 3 people. And what if I wanted to say return a list of all the people whose ages are less than 45? Okay, so I'm going to say db.people.find. And then as part of the selection criteria, I'm going to say look at the age property. But instead of just like age would mean specify a specific age, right? If I said 42, then it would get me the object with the age of 42. But if I want something that's a little more dynamic or a little more broad, I can pass in, instead of typing 42, I can pass in another object. And in this object, I can use one of MongoDB's search tools. For example, $LT. What do you think that is? Less than, yeah. LTE. Less than or equal. GT, greater than. GTE, greater than or equal to. So I'm going to say less than, 45. And then let's do .pretty just so it's nicer. For some reason, the first one isn't showing up. Okay, so here's my two objects, age 12, age 42, and that is what it returned because I did age is less than 45. That's just one example. There's also a $or, so you could say db.people.find and in here I'm gonna say let's say I want to find anybody whose name is Bob or anybody whose name is, or whose age is 79. Okay, in find, I can pass an array. Sorry, no, don't pass an array. I can say $or, and the syntax of these are kind of strange just because they're unfamiliar, but after a while they start to make sense and it's easy to look up. Or an array, and then the first, you'll have like a couple objects or however many things you want to search between. And so say like either their name is Bob or, and the second item in the thing, the age is, and then let's get even more complex. We can say $GT, so their age is greater than 30. Oh, I missed something. There's that guy, there's that guy, that guy. Oh, this needs to be in an object. See how crazy these braces are? There we go.
Why is that pretty not the first one?
Why is what?
Why is it not making the first one pretty?
I don't know. Because it's being obnoxious. So that ended up showing everybody because it got person with the name of Bob, but it also got the people whose ages were greater than 30. Okay. These search tools you don't have to have memorized. Playing around with them is helpful because there are certain instances in your code in Mongoose where you will revert back to the native MongoDB syntax of things. I'd always have to just do a Google search for it for the most part, for anything that's out of the like normal. But that's really easy to do. So now I'll show you how destructive you can be. Imagine this is like a fully fledged database. I'm running a business with like 1 million users, and I just decide that I am gonna be funny, and I say db.drop database, and it's gone. All my data is gone.
Awesome.
I say show DBs, there's no more puppies, sorry. All those puppies are gone. Well, people was a collection inside the puppies database. Yeah, so this deleted the whole puppies database. You can also drop a collection, just a collection, if you decide you don't need it anymore. It's db dot, like people dot drop parentheses, and that'll drop a collection. But this just dropped the entire database. And you can get out of Mongo by doing Control-C, and it's very kind and says bye.
How did you say you remove an entry document?
Single document is the dot remove that you had.
Oh. Okay, I got it.
It's like db.people.remove, and then the selection criteria. Oh, and that was something I didn't show. I could say like db.people.remove where age is greater than 30, and it would remove all the people whose ages were greater than 30. Wait, I think. I have to play with it. Let's see. Anyway, check out the post that I sent for additional reading. You can, yeah, there's a lot of search tools with MongoDB. Most of our syntax is going to be in Mongoose, so we're not going to like, dive too deep into this. But it can be kind of fun to play around in the database. And the next thing we'll do is start writing code to access our database and like structuring our collections and adding validation to the properties of the documents that we add into collections and everything using Mongoose. Where are we? 6, 7. What do you guys think? Databases are kind of fun. When we start saving your data and like you can query for data and it saves like whether you restart the server or you shut down your computer and start it back up, like refresh your page, the data's going to be there. And it's pretty cool. It'll be fun.
I thought drop database deletes all of it.
It's supposed to.
Excellent.